Note 1A for homework number 5, question 1. You can pause the video if you'd like to read the question. Looking at the diagram, we have 250-pound load at 0 foot, 250-pound load at 14 feet, 150-pound per foot distributed load, a roller support at A, and a pin support at B. To find the shear and moment diagrams, we have to find the shear and moment functions. First, we have to find the support reactions at A and B, and we do this by drawing a free body diagram. After drawing the free body diagram, we can write the equilibrium equations, and because of symmetry, the reaction forces FA and FB are going to be equal in magnitude. Taking the forces in the y direction, we get FA plus FB equals 1,400 pounds. Taking the moment at point A, we get FB equals 700 pounds. Plugging it back into equation 1, we get FA equals 700 pounds. Now that we have the reaction forces at A and B, we can now find the shear and moment functions. And we can do this by using method of sections. Starting from 0 to 4, we can make the cut and draw the free body diagram as shown. Taking the equilibrium equations, we get V equals negative 250 pound, and taking the moment at point O, we get the M equals negative 250x for the moment. Taking the second cut for 10 feet, we get the free body diagram as shown. Taking the equilibrium equations at Y direction, we get V equals negative 150x plus 1050 pound. And taking the moment at point O, we get M equals negative 75x squared plus 1050x minus 4,000 pound foot. And all of the distances for the moment are going to be shown here on the free body diagram. Now, taking the third cut for 10 feet to 14 feet, we get this as shown. Taking the equilibrium equation in the y direction, we get the shear of 250 pound. And taking the moment at point O, we get M equals 250x minus 3,500 pound foot. Now that we have the shear and moment functions, we can now draw the shear and moment diagrams. Looking at the shear diagram from 0 to 4, we have V equals negative 250 pound, which is a constant. From 4 to 10, we get V equals negative 150x plus 1050, which is a negative linear. And if we plug in 4 for the shear function, we get 450 pound. And if we plug in 10 for x, we get negative 450 pounds. For 10 to 14 feet, we get V equals 250 pound, which is also constant, which gives us the shear diagram. And for the moment diagram, we get from 0 to 4, we get M equals negative 250x. If we plug in 0, we get 0. And if we plug in 4, we get negative 1,000 pound foot. From 4 to 10 feet, we have M equals negative 75x squared plus 1050x minus 4,000 pound foot. If we plug in 4, we also get negative 1,000 pound foot, and if we plug in 10, we also get negative 1,000 pound foot. To find the top part of this downward parabola, we can take the derivative of M, which is also the shear function, and if we make this equal to 0, we get x equals 7. And we set it equal to 0 since shear is the slope for the moment, and the slope at the very top here is going to be 0. Plugging back in 7 at the moment function, we get negative 325 pound-foot. Lastly, from 10 to 14 feet, we have m equals 250x minus 3,500 pound-foot. Plugging in 10 for x, we get negative 1,000, and plugging in 14, we get 0. Looking at from 0 to 4, it has a negative linear slope. From 4 to 10, it's a negative quadratic function, which gives us the shape of a downward parabola. And from 10 to 14, we have a positive linear function.